starting with our actual session, let's get introduced with the organization through which we could bring such valuable and informative session. It's been more than 10 years. CloudThat is the leading organization for providing training and consultation services in multiple domains such as cloud, security, AI/ML, IoT, and DevOps. We have trained 500K plus professionals across different technologies and geographies. We at CloudThat have provided training deliveries for more than 100 plus corporates for all stages of employee lifecycle. Here, we have a strong consultancy team of 150 plus certified cloud experts who have successfully delivered 200 plus projects. We offer 400 plus cloud certifications in different domains. CloudThat is Gold Microsoft partner, AWS and Google Cloud Training partner, and AWS Advanced Consulting partner. I am happy to share that CloudThat had bagged Superstar Awards during financial years 2021 and 2023. So this is little bit about our renowned organization. Now let's get introduced with the today's speaker for the session. Myself, Priyanka Kapadia. I'm working as subject matter expert in GCP team at CloudThat. I'm Google authorized trainer and have multiple proficiency level certifications in Google Cloud, AWS, Databricks, and Kafka. I'm passionate to learn new technologies as big data analysis, machine learning, generative AI, blockchain, cloud computing, and many more. I have trained many participants on big data analysis, cloud computing fundamentals, GCP data and machine learning certifications, artificial intelligence, advanced Python, and Kafka. So this is little bit about myself. Along with me, I have Yatin Agrawal with me, who is working as a research intern here with me in the GCP team at CloudThat. He holds a passion of exploring new technologies and discussing those technologies with the number of participants. Yatin is going to help me for resolving your number of queries. So once again, we both welcome you all for today's session, which is based on what are the different services provided by GCP for handling big data. So let's move ahead. So this is going to be the agenda for today's session. First, initially, we will have the introduction, a brief introduction about the GCP and the big data. Then we will have the learning path and the number of certifications which you can have as a part of a GCP domain. We will have a brief introduction about what is the data pipelines, what is the role of data engineers. And apart from that, then we will move to the discussion about what are the different big data services which the GCP provides. Finally, we will have a small demonstration of one of the big data GCP service, and we will discuss a short brief case study in which all these different big data GCP services have been successfully used. And at last, we are going to have a short question and answer session. So let's get started. Let's have the introduction to GCP. GCP stands for Google Cloud Platform. So before getting into the GCP, let's try to understand what is cloud computing is all about. So cloud computing is nothing but where the number of resources which are in the form of a storage, networking, machines, computation power are provided to users through the internet. So instead of owning your own resources, instead of having the physical presence of your own resources, somebody has already created those resources for you and you will be using those resources. Okay, so this is nothing but this is a cloud computing. So at the third party or at the some different place, somebody has created number of resources. So this is a third party who has created number of resources. And you being the user, you will be using those number of resources which has been created by third party through the internet. So you don't need to have all those resources to be physically available at your end, but still you will own them. What are the different advantages of cloud computing? The first one is the on-demand self-service. So there is a less human intervention for getting up the resources. Through the use of internet, you can access those resources, and those resources can be accessed from anywhere in the world. Let's give the example of a virtual machine. So the same way we have machines on our table, in the same way we can have virtual machines which will be created at the data center of Google, and we will be using that particular virtual machine from our own machine through the internet. And whatever virtual machine you have created, that virtual machine will be created as per your configuration. You will be deciding what will be the configuration of your resources. Next is a resource pooling. So through the cloud computing, number of resources can be shared among multiple people. Rapid elasticity, we can get the more resources quickly as we need. For example, if I want to have a new machine, so the first thing is I need to go to the market. I need to make a choice whether I should choose for the HP machine, whether I should choose for the Lenovo machine. Once I have decided about my choice, I need to place the order for it. Once I have placed the order, next is that particular machine will be delivered to you. Not necessarily it will be delivered to you within few minutes. It may take an hour or it may take days for a machine to be delivered to your place, right? Future, whenever there is a need to change the configuration of those machines, then again, it will take lots of time, correct? So instead of that, because of cloud computing, change in the configurations, delivery of your virtual machines can be done quickly. Once you have created your virtual machine, in future, if you feel that I want to increase RAM of my virtual machine, or I need to increase storage size of my virtual machine, it can be done quickly. So this is nothing but this says about the rapid elasticity. Finally, measured service. Whatever amount of a time you will be using your resources, you are just going to pay for that particular amount of time, which we called as pay as you go. Which we called as a pay as you go model. So let's say if you will be using your machine just for one day, so you will be paying for that machine only for one day. Instead of investing or instead of making an investing for purchasing that particular machine, you can just pay for one day. So these are the basic advantages of cloud computing, a brief overview of different advantages of cloud computing. Now, next, the question comes, why GCP? We have number of cloud providers which are currently in the market, but why we should go for the GCP? First thing is cost effective. It is a highly scalable. It has provided number of custom machine types, and it has provided the support for Internet of Things. Whatever GCP services are provided, all those GCP services are in the form of APIs. It provides a number of services related with big data analytics, which we are going to focus today in our session. It also provides the huge support for cloud AI. It has number of tools which are in support of generative AI, machine learning. Next is, and the very important is, it is serverless. What is meaning of serverless? Here, you do not have to decide about the configuration of your machines. Sometimes, like some of the services which are offered by GCP, there everything will be clear. Everything. Yes, Satyanarayan. If you have any doubts, you can just put it in the chat box. Yes, Satyaraj and Raju, if you have any queries, you can put it in the chat box. Yes, participants, if you have any doubt, yeah, we are going to have the question and answer afterwards, but still in between of the session, if we have if you have any question and answers, then you can just put it in the chat box. Meanwhile, if you have, I have Yatin with me, so who can just help us for answering your questions. Okay. So we were discussing about the serverless. So in case of a serverless, most of the GCP services, configuration of the resources or the configuration of infrastructure will be taken care by Google. So most of the things will be managed by the Google. Let's move ahead. So these are the few of the leading companies which are successfully using Google Cloud for their production environment. Along with that, I am just going to discuss one success case study which is related with the Gojek. So Gojek is nothing but it is one of the company in Jakarta, and this particular company is into the ride hailing. So it provides the two-wheeler ride on a rent. The similar way in India we have Ola, we have Uber taxi. So similarly in Jakarta they have this Gojek service which allows for the two-wheeler ride. Apart from that, this service is also into the food delivery and the grocery shopping. This service has been almost started in 2015. After that, this service has developed, or this particular organization developed its own mobile app. Once they have developed their mobile app, they have seen that they have 190 million downloads for their app. They had 2 million driver partners which are associated with them. They have 900K merchant partners which are associated with that particular organization. With such a huge amount of association, it has been observed that this particular organization is receiving one ping every 10 seconds, 6 million pings per minute, and 8 billion pings per day. So if you can just imagine, it is generating 5 terabytes of a data per day. Now, where the question is, this amount of a data has been generated for Gojek, but Gojek needs to make some decisions. Whenever Gojek is providing such a number of facilities to its customers, that time Gojek needs to find out. Let's say if one of the customer has requested for the scooter ride, then Gojek application needs to analyze whichever is the nearest two-wheeler driver which is available for that particular customer. This is the one thing which Gojek application needs to think of. The second one is, if a particular customer is not satisfied with the Gojek service, maybe whatever food delivery that customer has requested has not been delivered in a particular amount of time or in a specified time. That's why the customer is not happy. So considering all these scenarios, Gojek needs to analyze such a huge amount of a 5 terabytes of a data every day. Now, if you consider this 5 terabyte, it's a very big amount of a data. For storing that amount of a data, for handling the real-time generated data, that's why Gojek needs to take help of some cloud. And for that, Gojek turned to the Google Cloud, and it has taken the help of some of the Google Cloud services like PubSub, Dataflow, BigQuery. Correct? So PubSub is a service through which the real-time data got ingested, real-time data ingestion, real-time data ingestion was provided by the PubSub. Then that particular data was ingested into the Dataflow service. Dataflow service is a data processing service. And finally, that processed data has been used for the analysis purpose. If we consider the network of a Google, then Google has its data centers into 37 regions, about in 112 zones, and it has a network edge locations which is around 187. It is widely spread across 200 plus countries and territories. These are the different categories of services which are provided by GCP. The first one is a compute. So under the compute, we have these services: compute engine, Kubernetes engine, app engine, and cloud functions. If we talk about the storage, we have Bigtable, cloud storage, cloud SQL, cloud spanner, and cloud data store. Now, when you come to the big data, this is where we are going to focus today. Here, we have the services like BigQuery, PubSub, Dataflow, Dataproc, and the Data Lab has been currently deprecated. Instead of that, we are using a Data Studio and the Looker Studio. Then we have a number of machine learning services like Natural Language API, Vision API, Machine Learning, Speech API, and Translate API. Now, if we consider the big data categories, today we will be discussing in brief about a BigQuery. Along with that, we will be discussing about the Google Cloud Storage, BigQuery, PubSub, Dataflow, Dataproc, and we will be discussing about a Bigtable. Apart from those services, we have different services under the category of networking and the cloud development tools and the management. Apart from all these services, there are few more services which are provided by GCP. So you can just refer those by referring or by visiting the Google Cloud website. So that's it about a brief introduction about GCP and the number of categories under which GCP provides its services. Let's move ahead and let's have a quick discussion about big data. We know that there are three important types of data. One is structured data, semi-structured data, and unstructured data. What is a structured data? Structured data has the defined schema. Defined schema means, let's say if I have the data about the employees. So what type of a data I am going to store about employees? The schema is decided. Structure is decided. Let's say I'm going to store about employee number, employee name, and employee address. So this is nothing but this is the schema for my employee details. So whenever I will be storing my employee details, I will be storing in this specific format only. This type of a data is called as a structured data. For storing such a type of a structured data, relational database management systems are used. So you must have heard about Oracle, SQL. Sorry. So all these are the relational database management systems which helps us to store structured type of data. Next comes is a semi-structured data. So in this case, the schema is not appropriately defined. So we can change the schema dynamically. This is called as a semi-structured type of a data. So JSON, CSV, XML, these are the different file formats which comes under the semi-structured data. So if you just remember, in case of a CSV file format, all the values are comma separated. So here the schema is decided or the schema is mentioned, but it has the flexibility that schema can change depending upon the different records which you are going to enter. The last one is the unstructured. So in case of an unstructured type of a data, everything unstructured, nothing is fixed, no schema is fixed, no structure is fixed. The best example, if we talk about the unstructured data, is we have audio files, video files, log files, images are nothing but unstructured type of a data. So currently in the market, we have almost 98% of a data which is unstructured data, where the format is not fixed, no structure is fixed. What is big data? So big data refers to the data which is very large. We know that this data is getting used from the years, but after the data, the term big data came into the picture, right? So big data is nothing but a huge amount of a data. Initially, we were just handling GB of a data, but now currently we have a terabytes, exabytes of a data, nanobytes of a data, and the data has been increasing tremendously, exponentially day by day. Okay, so by 2025, it's estimated the global data sphere will be grow to the 175 zettabytes. Correct? Now, these are the important characteristics of big data. And because of these characteristics, handling of big data is the biggest challenge. These characteristics are considered to be 6 V's of big data. First one is a volume. Almost every one of us have smart gadgets with us. Smart gadgets, if I talk, the smart gadgets are nothing but the gadgets who are connected with internet, and those gadgets are generating data for every millisecond or microsecond. All the gadgets are generating one or the other type of a data with every nanoseconds, with every microseconds, right? So this is called as a volume. So volume is the one of the biggest characteristics of big data, the amount of data generated by multiple sources, correct? Variety. Now data is not just restricted with the structured format. Data is getting generated in number of ways and in number of formats. Now the way I'm delivering my session, so this is nothing but this is the way of audio, correct? But along with that, even the transcript of my session is getting generated, which is nothing but which is a textual data. So audio data and the textual data, these two are completely different formats. So here is nothing but it is what the variety of data is getting generated. Velocity, the speed at which the data is getting generated. The way I'm delivering my session throughout the world, so many different people, different speakers will be delivering their sessions. So this is the velocity at which your data is getting generated. Veracity. So, the important, yesterday only we had successfully launched, we have our Chandrayaan-3 was successfully landed on moon. So that was the great success for India. If you just imagine about the working of Chandrayaan-3, so just imagine how much amount of a data the Chandrayaan-3 application must be referring, must be analyzing, and what type of a data it has been analyzing or it has been using to make the decisions. Because the algorithms in Chandrayaan-3 was made, or it was designed in such a way that Chandrayaan 3 itself decided where to land. It was not the scientist who decided where the Chandrayaan will be landed. Chandrayaan made the smart decision for the landing position. And how it made that decision? By analyzing the different data which it has been collected. Correct? So just imagine the amount of a data which it has collected, and the type of a data it must be analyzing, and the speed at which the data it has been receiving. Okay, and the veracity, the most important characteristics of the big data is, though we are generating a data, though we have a data, the next comes is the authenticity of a data. Whatever data has been received, that data has been received from the trusted sources or not. So here the question of authenticity comes into the picture, or the trustworthy data, whether my application is receiving trustworthy data or not. Value, whatever data I have collected, how much data is really useful for the analysis purpose. So is that particular data, how much actual data is going to add value to my business? That is also very important to decide. Variability, the ways in which the big data can be used and formatted. So everywhere, everybody is using your data in different formats or in the different aspects. Okay, so these are the six important characteristics of big data. Now, what are the different challenges? We have the biggest challenge, which is nothing but the data quality. Whatever data has been received, who ensures the quality of data? Whatever data has been collected, are there any errors which are available in that data? Data integration. Currently, for a single application, data has been received by the multiple sources. For example, let me just give all these challenges with the example. Let's suppose I have one healthcare application. This is my healthcare application. This healthcare application is receiving data from my smartwatch, which I am wearing. Along with that, some of the doctors are also feeding data into my healthcare application, right? The doctor whom I visit frequently, or who is my family doctor. So this doctor is also giving the information to this healthcare application, maybe at a particular time interval or periodically, right? So just imagine this particular single application is receiving data from so many multiple sources. And most importantly, whenever healthcare application is receiving data from this multiple sources, format of that data will be different. It might possible that doctor is just filling a form related with my health values, and the data is getting entered into the healthcare application. Smartwatches, IoT sensors are feeding data into the healthcare application, right? Or it might be possible, let's say, for some laboratories where I have visited for the healthcare checkup, that laboratories are also feeding the data into healthcare application. Correct? Now, data quality, whenever such a huge amount of a data related with my health is getting fed or it getting ingested into the healthcare application, who ensures the quality of data? That means the data, there are no missing values, right? The data which does not have any outliers. So in case of a data quality and data errors, you need to take care of the outliers. You need to take care of a missing values. Finally, we have a data integration. Whenever the data has been received by such multiple sources, The thing is, you need to integrate it, you need to combine that data. Then we have a talent gap. As I just mentioned previously, just imagine of a 15 years back, there was no concept of a big data. Concept of data was there, but not the big data. So between this 15 or 20 years or the 25 years, this big data has increased tremendously. The concept of big data has been increased tremendously. But do we have people, do we have uh, technical people who can handle, who can manage this huge amount of data, who can work on this huge amount of data, who can have the quality data from such a huge amount of a data, using which the proper analysis can be done, right? The next is a storage and the network. Will this huge amount of data can be easily stored? Where it will be stored? So you need to think of the storage options. When such huge amount of a data is getting generated, how it will travel through the network? Do we have such an efficient network? Then timeliness of analysis. The moment data has been generated, immediately it has to be analyzed. For example, whenever my smartwatch has generated any data related with my health, immediately the decision has to be taken whether I am doing well or not. This has to be done at that particular moment itself. If my smartwatch has generated some data related with my health and my health condition are not good, but this particular analysis has been done after 1 hour, then it will badly impact on my health, it will badly impact on my life. So the importance is timeliness of analysis. The moment data is generated, immediately it has to be analyzed, it has to be verified, it has to be analyzed to make some decisions. Security and privacy. How to secure such a huge amount of a data? Nobody should attack on a data center, nobody should attack on the storage house, and nobody should steal my data. We have discussed, we have seen in newspaper how many such data scams has happened from previous few years. Previously, the recent biggest data scam which has happened, the data hack which has happened in India was data related in EMS. Okay, patient data in EMS was stolen, was hacked, correct? So again, this security and privacy is a major challenge in case of a big data. Powerful data analytics. When we have a huge amount of a data, we need some tools which can powerfully analyze that data. And once your data will be analyzed, then only proper decisions will be made for the businesses. So these are few of the big data challenges. Let's see how our GCP services will help us to handle all these big data challenges. So before moving to our actual service discussions or actual discussion about GCP services, let's have the introduction to the learning path and the certifications. So these are the certifications which are provided by GCP. So we have a basic certification, which is a cloud digital leader. Then above that, we have an associate level certification, which is an associate cloud engineer. And we have a professional level certifications, which are cloud architect, cloud database engineer, cloud developer, and data engineer. So if you are really looking into studying about the big data services and you are really looking into mastering into number of services which are provided by GCP for handling, for managing data, then you should opt for this data engineer, professional data engineer certification. Okay, so these are all the professional level certification. So this is a certification which is the right one if you are looking for having your career in data track. Okay, and apart from that, if you are into the machine learning, then you can surely go for this particular certification. Okay, so GCP provides 9 professional level certifications. So as per your choice, as per your interest, you can select any one of it. Right. Let's move ahead and let's discuss the what is a data pipeline and what is the role of let's discuss about what is a data pipeline and what is the role of data engineer. So we know that for a particular application, data gets generated from number of external sources. I'll just take my healthcare application example back over here. So I have healthcare application. This is my healthcare application. This particular healthcare application is receiving data from the number of external sources. From somewhere it is receiving the data into the XLS format, somewhere IoT sensors, somewhere .csv file. So this different type of a format or this data in the different format is getting ingested into my healthcare application. So whenever I am receiving this a huge amount of a data, the first thing I need to take care is I need to have the quality check of this data, right? So once you have data, you need to have the quality check of that data, which we called it as a you need to process the data. So whatever raw data you will receive, the first thing is you need to collect that entire raw data all together. You need to store that raw data all together and then process that data for the quality check. And finally, whatever is your process data, whatever is your good quality data, finally, you have a good quality data. This data is ready for the analysis. Okay. So ingestion is nothing but getting a data from the multiple external sources, receiving data from multiple external sources. And always remember that whenever you will receive your data from the multiple external sources, it will not be just 1 GB of data. It will be huge amount of a data. Huge data, right? So you will require that much amount of a storage space for handling such a huge amount of a data. Maybe it will be 50 terabytes of a data. So you need to provision for that much of an amount of a storage to store 50 TB of a data, correct? So once it has been ingested, the next thing is storage. Now, whenever the data will be stored over here, this is nothing but this is your raw data received by the multiple sources. So you need to raw data collected all together from all different sources, right? And finally, you have a process and analyze. So now this is your raw data. Finally, you need to process your data and you need to get your data into the good quality data. Good quality data means you should not have or your data should not have outliers. Your data should not have missing values. Your data should not have null values. Your data should have in a proper format which is required for the analysis. For example, whenever you have collected your data, let's say you have collected your data of date of birth. So you have collected your data as 02051980. So this is the way you have collected. But whenever you are analyzing your data, you are not interested in date of birth. For the analysis of purpose or for the analysis purpose, we are interested in age. So in that case, whatever date of birth is there, you need to convert it into the age value. So this is called as a transformation, or this is nothing but this is called as a representing your data in such a format that it will be useful for the analysis. So the we can also say that you need to represent data in required format. And finally, once you have a good quality data, then the analysis can be done. And finally, whatever analysis has been done, you need to represent that analysis in the form of graphs. Why we need to represent our analysis in form of graph? So that it will be easily understood by business people. It will be easy for the non-technical users to understand what is going inside the data, what outcome I can have from data. So graphs to have the good insight of data, and this is helpful for decision making. How much amount of a sale has been done in the month of March, in the month of April, in the month of June? If such a data has been represented in the graphical format, if such data has been represented in the graphical format, May, June, July, and August. So this is a sales data. So if the sales team have this data into the graphical format, immediately sales department can make some type of a decisions with this data. Okay. So these are nothing but this entirely is called as a data pipeline. So data pipeline starts from collecting your raw data from the multiple sources, formatting that data, processing that data so that it will be useful for analysis, and finally visualizing that data, visualizing whatever analysis has been performed. So this entirely is called as a data pipeline, right? So data pipeline is nothing but managing your data and making your data ready for analysis. Here, in case of a data pipeline, there are two important terminologies which are nothing but which are data lake and a data warehouse. There are two important terminologies, data lake and data warehouse. So data lake is nothing but where you have a raw data, and data lake is nothing but, data warehouse is nothing but where you have a process data. Process data means good quality data. So both of these are nothing but the storage solutions or the storage options. But in case of a data lake, what type of a data is stored? Your raw data will be stored. The way it has been received from the multiple sources, it will be stored as it is. And once you have processed that data, you have cleaned that data, whatever is the good quality data is there, it will be present in data warehouse. Okay, so please remember these two important terms, data lake and data warehouse. Now, next we have the role of data engineer. So if you are thinking to create your career in data, or you must have heard about these three roles or the three career options in the recent IT fields: data engineer, data analyst, and data scientist. So now what is the role of data engineer? So basically, data engineer is responsible for collecting and processing data. So basically, data engineer is responsible for creating quality data. So once your raw data has been received, how to or what type of a transformations need to be performed on that data, so eventually we will have the good quality data. This is the role and responsibility of data engineer. Next is a data analyst. Once you have a good quality data, once you have a good quality data, what operations needs to be done on that good quality data, so that whatever will be the output, that output, using that output, business people can make its decision. So data analyst is going to perform the analysis on good quality data to make decisions. Correct? And finally, data scientist. So the role of data scientist or the responsibilities of data scientist is development of machine learning algorithms. Machine learning models, rather, I'll say. So using the machine learning models, what is done is prediction of future. Now, in my previous graph, when I showed you the sales data, so this is my June, July, August, September is yet to come. Okay, so June, July, August data is there. So this is nothing but this is my analyzed data. From this analyzed data, the sales team will decide that, or sales team will take the decision that in month of July, we had the highest sale. With this data, sales team will have the decision that in month of July, we had highest sale. Correct? This is nothing but this is the role of data analyst. Now, representing data in this format is the role of data analyst. Now, what is the role of data scientist? Predicting what will be the sale in month of September. Predicting what will be the month, what will be sell in the month of September. So writing the algorithms, creating the machine learning models for this prediction is the role and responsibilities of data scientist. So now you decide in which field you are good at. If you are good at understanding data, if you are good at finding out why this data is not good or where something is going wrong, then go for the data engineer. Or if you are currently working as a data engineer, then this options or this understanding may help you to switch your career roles or switch your job paths. Correct? So these are the three important roles which are in the field of data currently available. Correct? Let's move and let's with the overview of a GCP Big Data Services. Correct? If you have any questions and queries, either we can take it at the end of the session or simultaneously you can put it in the chat box. So the first service which I will be discussing is a Google Cloud Storage. Before proceeding with the actual discussion of Google Cloud Storage, let me just give you the brief introduction about the Google Cloud Storage. So let's have the brief understanding about the Google Cloud Storage. So Google Cloud Storage is nothing but the object type of a storage. It is the object type of a storage. Next thing is we can store any amount of a data using a Google Cloud Storage. There is no limitations on storing the data. In case of a Google Cloud Storage, you need to create a bucket, and inside this bucket, your data is stored in the form of an object. This bucket is uniquely identified. Next, it also provides the options of different storage classes. It provides the support for lifecycle management. It provides the support for object versioning. It provides the support for encryption. Encryption and fine-grained access. Okay, so these are the few more things, few more features of Google Cloud Storage. Now, in Google Cloud Storage, as I have just mentioned, it is an object storage. Object storage means if I want to store video file. So video file is nothing but it is one object. If I want to store text file, so text file is nothing but one of the object. So I can upload that file as it is in my Google Cloud Storage. Okay, but before uploading that object, first thing is I need to create a bucket. So once I have created a bucket, in this bucket, I can have my different objects. Let's say this object may be .txt file. This object may be .mp4 file. I have one more object which is .xls file. Right? So there are no restrictions on how many objects, how many files you will be storing in your bucket. Only restrictions is the maximum size of each object should be 5 terabytes. Maximum size of each object should be 5 terabytes. But such 5 terabytes objects, you can store any number of 5 terabytes objects. Okay. Next, the name of this bucket should be universally unique. Finally, whenever we are storing objects inside a bucket, Google has provided different storage class options. So depending upon in which storage class or using which storage class option you need to store your object or you need to store your bucket, you can make decision about it. And depending upon the different storage classes, price also differs. So if you are storing your data into the standard storage class, you are going to pay more. But when you are paying more, the amount of time which is required for retrieval of your object is the less. So you can have or the retrieval of object is faster if your object is present in the standard storage class. So like that, Google Cloud Storage has a 4 storage classes options which are provided. Lifecycle management. If your object has not been used for 30 days, it will be automatically moved to the other storage class just to save on money. So if you set the lifecycle management policy, if you say that if my object has not been used for the 15 days, let's move this object from the storage class to the cold line class. Then this will be done automatically. We have the object versioning. Currently, I have uploaded one object, I have uploaded one text document. Tomorrow, if I try to upload the text document with same name, but the contents are different, then we have the different versions of that object. Finally, encryption and the fine grain access. Whenever your object will be stored, that time that object can be stored in the encrypted format. Now this encryption is done using the Google provided keys, or even the customer is allowed to provide its own key. Fine grain access. Who is allowed to access your object? If you want to make your object publicly accessible, then that particular object can be used by other people throughout the internet using the URL. Or else you can decide who should use your object. Correct? So this is about a brief thing. Now we will just have a sketch note of a Google Cloud Storage. Here, what is a Google Cloud Storage? So Google Cloud Storage is a global service, secure, scalable object store. We can upload any type of a document in the Google Cloud Storage bucket. Here, if you can see PNG or the JPEG, that is a document has been, picture document has been uploaded. After that, we can have the movie file. Next is, how does it work? So you can upload your object inside a bucket. This particular bucket can have the different access levels at the project level or at the organization level. So you can decide about the access level permissions, whether it has the access level permissions at a particular project or at a particular organization. That can be decided. It has 4 storage classes: standard, nearline, cold line, and the archive. If whatever object you have stored, if that particular object is getting frequently access, or you want your document, you want your object to be highly available, then you can choose for the standard class. Then nearline. So let's say if your object has not been used for a 1 month, then it will be moved to the nearline class. Finally, cold line. If it has been observed that your object has not been used more than 30 days, then it will be moved to the cold line. And finally, if it has been observed that your object has not been used for more than 90 days, then it will be moved to the archive. Storing data as a part of an archive class, storing data as a part of an archive class is always going to cost you less. This is called as the object lifecycle management. Apart from that, it also supports for the auto versioning or the object versioning. Clear? How to use the Google Cloud Storage. If I want to add my object, if I want to put my data into the Google Cloud Storage, how I can do? The first one is you can directly use Google Cloud Console. Next is we can use the multiple transfer services to transfer data from our offline storage to the Google Cloud Storage. Or we can use the different utilities. We can use the client libraries which are available for transferring our data to the Google Cloud Storage. There are number of client libraries which are available in Python also, which can be easily used. Correct? Now, if it comes to the security for the cloud storage, then encryption at rest. Encryption at rest means whenever your data will be stored with Google Cloud Storage, that data will be stored in encrypted format. That data will be stored in the encrypted format. Now, whenever it comes to the encryption, who is responsible for managing the encryption key? So again, here there are two options. Either Google can manage the encryption key, or if customer wants to manage encryption key by himself or herself, then that option is also allowed. Apart from that, as I just mentioned, whatever objects you have in your bucket, you want them to be publicly accessible, then you can set it in that particular way. But if you want to prevent public access for your objects, then you can specify that type of a configuration also. Finally, what is a pricing? If we talk about the pricing, then in case of a standard storage class, you need to pay more. In case of a nearline, it is comparatively lower. Cold line, much comparatively lower. And in case of an archive, it is the most list pricing. But the only thing is, if your object is in the archive, it is going to take larger amount of a time for the retrieval. Correct? Now, where we have or where we can use the cloud storage, the most important use of a cloud storage, or apart from storing your data, the most important use of a cloud storage, or it is recommended, if we think from the data pipeline perspective, Google Cloud Storage is advised to be used for creating data lake. It is advised to be used for creating data lake, because data lake is the place, or it is the storage place where data from the multiple sources are collected together and stored. And whenever we are receiving data from multiple sources, those data can be in different formats. And we have just seen in Google Cloud Storage, data in any format can be stored. So whenever you are collecting data from the multiple sources, and you want a single place to store that data collectively, then we have the Google Cloud Storage. So Google advises us to use Google Cloud Storage as option for creating data lake. Okay. Now the next very important service is a BigQuery. BigQuery is considered to be the enterprise data warehouse. So once you have your data as a part of a Google Cloud Storage, or whenever you have your raw data, next comes is you need to process that data, you need to analyze that data. So once you have your data which has been processed, which has been transformed, how you will transforming your data, that we will see afterwards. But once you have quality data, you can keep it into the BigQuery. If we talk about the BigQuery, then BigQuery is nothing but it is the columnar data storage. And BigQuery is basically used for the OLAP type of operations, OLAP operations. So whenever you need to perform the analysis of your data, then you can go for the BigQuery. Again, in BigQuery, there are no restrictions on how much amount of a data can be there. As I mentioned, in BigQuery, we can perform the analysis type of operations. So this analysis type of operations can be done how? So we can perform all this analysis type of operations by writing SQL queries. Now, what is mean by analysis? As I just mentioned, I need to find out how much amount of a sale has been done in month of June. So this is nothing but this is the analysis. How much amount of a sale has been done in the month of June. So to find out the value of this sale amount for the month of June, I can write the SQL query. Right? So in BigQuery is a columnar data storage. Any amount of a data can be stored and OLAP operations can be performed or the in form of a SQL queries. So whenever you have a good quality data, that good quality data can be kept in BigQuery and it can be easily analyzed. Apart from that, it does not just support for the analysis. Using this SQL queries, using the syntax of SQL queries, using the syntax of SQL queries, you can design ML model. So you can create the machine learning models also. So they have provided the SQL syntax for creating, for developing machine learning models, which is named as BigQuery ML. Okay. Important part of a BigQuery is you can handle both type of a data. You can have the batch data also and the streaming data also. Batch data is nothing but the collective data. Data which has been collected for the entire day. And for that entire day data, if you are performing some analysis, we call it as a batch data. Streaming data is nothing but a data which is receiving for each and every moment, is called as a streaming data. So in BigQuery, you can perform the analysis on both type of a data which has either be batch data or the data which is continuously generating data. BigQuery has the storage and the computation resources different. So in case of a BigQuery, there is a separation between storage and computation resources. So in case of a BigQuery, storing data, BigQuery has a different allocated resources for it. For processing your data, BigQuery has a different number of resources which has been reserved. So there is a proper separation for BigQuery. There is a proper separation between storage and the computation resources. In BigQuery, you can create data set, you can create a table. We will see it in the demonstration. So in BigQuery, the way we create database in our Oracle or in MySQL, same way here also we can create a data set, and inside a data set we can create number of tables as per our business requirement. If we talk about a more unique features of BigQuery, we have the BigQuery Omni. So BigQuery Omni is a service in which your data is not present in BigQuery. If your data is available in some other cloud, let's say if your data is available in AWS, but still using the BigQuery console, using BigQuery service, you can write down the queries or you can perform the analysis on that data which is stored in AWS or in any other cloud. So this is called as a BigQuery Omni. BigQuery ML, which we have just discussed. So it allows you to create the model using the SQL syntax. BI engine. Now, whatever analysis you have performed on the data by writing SQL queries in BigQuery, those analyzed data can easily be represented in a visualized format, in a graphical format, using some other tools. So BigQuery has the integration, or BigQuery is easily integrated with some other business intelligent tools like Data Studio, Looker Studio, Connected Sheets. So whatever analyzed data you have, whatever output you have got after execution of SQL queries, it can be immediately represented, or it can be represented in the visualized format. BigQuery SQL also supports for handling a geospatial data also. Then the recent advancement in the BigQuery, we have a data Q&A. So data Q&A is nothing but a service which allows you to write down your query in a natural language. Data Q&A is nothing but it allows you to write down your queries in the natural language. Right? Now the next is how the BigQuery works. So we can have the data, which is a batch data, which can be ingested. We have the streaming data. Streaming data is nothing but the data which has been received by the IoT applications, web application, or the mobile applications. Then if we have the some process data, this process data has been generated by the other tools that can also be ingested in BigQuery. Using the different data transfer services, the data can be ingested into BigQuery. Apart from that, the most important is BigQuery has its own public data sets also. So BigQuery has also provided set of public data sets. So if you want to just try something with the already available data set, you can surely do it. Once you have executed the query, the results of query can be visualized using these different tools which are integrated with BigQuery. If we talk about the security perspective, then we have risk of a data, we can avoid the risk of a data loss. We have a identity and access management. As I mentioned that we can create a data set. Now this particular data set can be used by whom? It can also be restricted by creating IAM rules and providing them with the required permissions. There is a VPC control also. Apart from that, whenever the data will be stored in BigQuery, we can also have it into the encrypted format, or the encryption is also provided. If we talk about the pricing of BigQuery, like whenever the data will be there in the BigQuery, so the pricing is calculated based on how much amount of a data has been processed. How much amount of a data has been processed. So in that case also, query up to the 1 terabyte is free. So for 1 month, if you are querying or if you are processing 1 terabyte of a data, it is free of cost. And whatever charges will be there, after that only the charges will be calculated. Here also in case of a query, you have on demand and flat rate. That's why basically in BigQuery, the storage and computation, both of them are different. So if you are storing 1 GB of data for 15 days or for 30 days, 1 GB of data for 30 days, your prices will be different for that. But let's say, considering that 1 GB of data, you are using more processing power, then for that the pricing will be different. That's why there is a proper decoupling, proper separation between the storage and the computation resources. Apart from that, we have a nice service which is called as a data loss prevention. Data loss prevention service. So this DLP service allows to identify sensitive data which has been stored in BigQuery. Okay, so this is all about two important services which are provided by GCP for handling big data. So while concluding BigQuery, I just pointed with one service which is called as a DLP. So DLP is nothing but data loss prevention API. So in case of a DLP, whatever data you currently have, I hope I am audible to each one of you. Is it? Yes, participants, I am audible to each one of you. Yeah, thank you. Okay. So DLP stands for data loss prevention. So in this case, whatever data you have, in that particular data, what data is a sensitive data and what data is not sensitive data. That can be clearly categorized or identified using DLP. Not just the identifying sensitive data, but if sensitive data is present in your database or in your data set, then how to handle that sensitive data will also be done using DLP service. So there is a good integration of DLP with BigQuery. So whatever data has been stored in BigQuery dataset table, so this DLP can work on that data to identify and to mask sensitive data. Okay. Let's move ahead and let's discuss with the next service, that is a big table. So if we talk about the big table, so a big table is nothing but it is a fully managed petabyte scale, no SQL database. Again, this particular service is based on the columnar storage. So it is a NoSQL columnar storage database. Now, where to use big table? So big tables are basically used for heavy read and writes operation. So for your application, if it has a huge amount of reads and writes operation, then the big table comes into the picture. In case of a big table, again the storage and the processing resources are separated. It provides the high level of a scalability. That means whenever the big table or whenever the data is getting stored in BigQuery, in big table, or whenever the data is getting processed in case of a big table, that time if any of the resource fails down, or if there is a situation where this particular resource is not fulfilling the requirement, immediately new resources will be allocated to take care of processing or to take care of storage, right? Apart from that, big table also provides high throughput and low latency. So this is the important features of big table over the BigQuery, that it has the optimized throughput and the low latency. Now, why it could provide the optimized throughput? The first thing is it separates the processing from the storage. So because of this, each node has access to the group of database rules. So if you have a collected data, so that particular data can be accessed by the multiple processing resources. And because of this, the same data can be processed parallelly, which will be faster. If any of the node is getting highly overloaded, then there is a proper rebalancing of a work which is possible. Resizing of a nodes is also possible if one of the node fails. Now, when I talk about failure of a node, that means if computation power fails, or whichever node, whichever machine is providing the computation power for big data, for the big table data, if that particular node fails, then who will take over the computation task which has been performed by that failed node? So here again, there is no manual intervention. It is automatically done in case of a big table. Now, where the big table is majorly used. So big table is majorly used in real-time analytics, or it is majorly used in those applications where there is huge amount of reads and writes. So basically, big tables are used, or the big table is used in fintech, adtech, gaming, and the IoT applications. Let's have a quick difference between the big table and BigQuery. So in case of a big table, it is a NoSQL columnar database. Whenever there is a requirement of high read and write events, read and write operations, that time big table is the good choice. Now, when we say that read and write operations, most of the time that is considered as a transactional process, OLTP. So it is called as a transactional processing. So whenever for your applications, most of the data is in the form of a transactional processing, or there is a requirement of a transaction processing, then we call it as a heavy read and write operations. It provides the single milliseconds of a latency. It is used in the real-time analysis of a large data sets. The next is where the BigQuery comes into the picture. So BigQuery is for the analysis purpose and for the reporting. That means whatever the result of analysis, if it has to be represented in the visual format. So whenever it comes to the decision making task, right? If business needs to make some decision, in that case, business needs to have some analysis, need to have some insights of data which has been collected. And providing this insight, providing this analysis is the job of BigQuery, which is done. Okay. Now, I have continuously talking about the batch data and the stream data. So let me give you the best example of a batch data and stream data. If I want to calculate how much amount of a profit has been earned throughout the day, so in that case, whatever sale has been performed in my shop from the 10 a.m. in the morning till 9 p.m. in the night. So I need to have this entire data all together for calculating profit earned throughout the day. I will not require the hourly data. I will require data for this entire duration. This is called as a batch data. And using this data all together, I'm going to analyze, I'm going to calculate the profit which has been earned in that particular day. This is called batch data. The other example is a stock data or the stock market. We know that share prices goes up and down each and every moment. How these share prices are calculated? So depending upon different businesses, how much they are selling or how much they are performing well in the market, share prices goes up and down. And this up and down in share prices are calculated at each and every moment, at each and every second. Whatever the way your business is performing in the market, share prices changes. So this is nothing but this is a continuous analysis which is performed. Here, we do not wait or the share prices do not change at the night 10 p.m. It is changing every moment. So this is called as a real-time data. Now the biggest challenge is how this data should be fed, how this real-time data should be collected. So for that, we have one service which we called as a pub sub. Pub stands for publisher, sub stands for subscribe. So this pub sub service is nothing but it is the event-driven asynchronous messaging service. In this case, here we have a pub sub. So the moment event has been generated, the moment data has been generated, it gets published into a topic. So here there is a concept of topic. So whenever some of the data has been generated, immediately it will be put into the topic. And from the same topic, the subscriber will keep on reading. The subscriber will keep on pulling that data from the same topic in which your publisher has written, your producer has written the data. So continuously producer is writing data and continuously subscriber or the consumer is pulling that data. And once the consumer has pulled that data, it will keep on working on that data. Right? So this is essence of PubSub, working of a PubSub. Cloud PubSub is derived from the concept of Kafka. Kafka is a very popular distributed messaging system which is widely used in number of organizations. So PubSub is basically derived from the Kafka itself, the concept of Kafka, but it is Google's its own service, right? Here at the last, you may see that you can see that how the PubSub works. So here the publisher is publishing a message. Publisher is nothing but, let's say, some of your IoT devices who are generating data. So they are generating the messages. Those messages are put into the topic. Topic is nothing but it is a kind of a message storage. It is a kind of a message storage. And subscription is nothing but a subscriber from where the data is getting read. So subscriber is reading the data from the same topic to which it has been subscribed. Right? For subscriber to read data from the topic, first it has to be subscribed for that topic. We can read a particular magazine only if we have subscribed for that magazine. Here also, subscriber is nothing but some of the service or some of the tool who is going to make use of that data. So subscriber needs to subscribe with that topic, then only it can read data from it. And once it has read the data, the acknowledgement will be sent and data will be deleted from the message storage. Once the subscriber has read the data, has consumed the data, has consumed the message, it will be removed from the message storage. Okay. So this is how the PubSub works. We will see this in the demonstration part also, not in much details, but maybe you may have the idea for that. Now, how the PubSub works, it is, we can have the multiple publishers, we can have multiple producers. Both of those producers are producing data to the different topics, but our subscriber can read data from two different topics. So we can have multiple publishers, but one subscriber. We can have multiple publishers and a multiple subscribers also. So it is a kind of a many to many relationship. Apart from that, we have one publisher, but we have a multiple subscribers, which is one to many kind of a relationship. How this PubSub helps in the stream analytics. So in case of a stream analytics, if we can see mobile applications or the web application or the IoT application who are continuously generating data, and that data is received in the PubSub. So all this data which is getting generated by all these different applications, those data is getting written into one of the PubSub topic. So these applications are nothing but the publisher of data. Next, that particular data is getting read, or that particular data which has been written into the PubSub topic is getting consumed by one of the GCP service, which is a data flow service. So this data flow service, one, it has read the data, it is processing that data, it is representing your data into the required format. And finally, that processed data, that good quality data is stored into the BigQuery or into a big table or into the Vertex AI, where it is getting used for some analysis purpose. And whatever the analysis has been done, whatever is the output of the analysis, finally, it is getting visualized, it is getting represented in a graphical format using some other BI tools. Okay, so here we have the role of a PubSub. So basically, PubSub is a service which is used for ingesting real-time data into Google Cloud. Now, I just mentioned in the previous slide about a data flow. So what is a data flow? In data pipeline, we discussed that first we have a data lake. So data lake is nothing but it is a storage house where you have your raw data, but that raw data is the data which has been collected from the multiple sources. After that, the data from data lake needs to undergo some kind of a processing so that eventually we will have the good quality data, right? Data which is present in data lake needs to undergo some kind of a processing. So eventually we should have a good quality data. And this good quality data will be then stored in BigQuery. So data flow and the next service which we will be discussing, which is a data prop. So these two services, data flow and data prop, are responsible for processing data so that your data will be represented in the format which is required for performing analysis. So eventually your data will be in a good quality. Okay, so this is what is the rule of data flow. So data flow, it is a serverless. Serverless means you do not have to manage the configuration of resources. You do not have to overhead about the configuration of resources, right? After that, it is a data processing service, and importantly, it can process both type of a data. It can process your batch data also, and it can process stream data also. Eventually, one more very important thing about the data flow, working of data flow is based on the Apache Beam. So Apache Beam is one more technology, or we can say it's a tool using which processing task is designed, and eventually that processing task is executed by data. So Apache Beam is responsible for designing what processing has to be done on data. And data flow is responsible for execution of that processing task. This processing task is represented in the form of a directed acyclic graph. Whatever processing, whatever transformations has to be done on data, that is represented in the form of a DAG. And finally, this data flow is responsible for execution of that DAG. Now, how this data flow works? So here, if you can see, read the data from the data source, perform some transformations if you want, and write data into the data sink. Okay. Now, this process is similar with your ETL process, if you have heard about it. ETL is nothing but extract, transform, and load. In case of an extract also, data from multiple sources is extracted. T means transforming your data, and load is nothing but eventually loading your data into some other system, into some sync system. So this data pipeline is more or less, it is similar with ETL process itself. So eventually we are going to write data into the sync system. Now, whenever the transformations are getting performed on the data, so those transformation processing is done using a Apache Beam syntax. So if you are writing your own pipeline, if you are writing your own transformations, then we need to make use of a Apache Beam syntax. So in case of a Apache Beam, each and every data is represented into the P collection, and then we have the P transformations which need to be performed on those data. In case of a data flow also, it is a distributed kind of a thing. It is a parallel working. So whenever data flow is executing its task, that time this task gets assigned with the multiple worker nodes, and all those worker nodes are executing the task in parallel. Okay, so here you can see worker virtual machine. So we have a multiple virtual machines who are working as a worker nodes. Finally, how to use the data flow. So now there are multiple ways of using a data flow. The first thing is we can write down the data flow job using the SQL. Second is data flow has provided their own templates. Data flow has provided its own templates. Finally, we can write down our own pipeline code using the Apache Beam syntax. Now that pipeline code can either be written in Python or it is written in Java. So we are going to see in demonstration part how the data flow works, and in that working we are going to consider the template. When it comes to the security, so in case of a security, we can turn off the public IP addresses. We can have the VPC controls over here. We can have the customer manage encryption keys also. There is a avoidance of a data loss, risk of a data loss, because it is highly available. If one of the machine is not working, immediately the other machine will be available to take charge of it. If we talk about the pricing of a data flow, so in case of a data flow, per second billing is done. We have a both type of a data which can be handled. It also supports for the auto scaling. As I mentioned, if one of the worker node, if currently we have a 3 worker nodes who is performing the processing, and those 3 worker nodes are not sufficient, then immediately few more worker nodes will be added. And whenever those worker nodes will be added, that time only those worker nodes, the cost of working of those worker nodes will be considered. Once again the computation has been reduced, or the requirement of a processing has been reduced, depending upon that, few of the worker nodes will be stopped. And once those worker nodes will be stopped, your prices will be down, or there is a decrease in price amount. Okay, so this is all about data flow. So please remember that data flow is a data processing service which can handle both the streaming and batch data, and it works on the Apache Beam concept. As I mentioned, along with the data flow, we have one more data processing service which is a data proc. Now, majorly, data proc plays an important role in case of a Hadoop. We know that for handling big data, Hadoop, what is a Hadoop? Hadoop is nothing but it's a tool, or it's a framework, whatever you can say. It's a tool for handling, for managing, for storing huge amount of data, right? Hadoop is a very renowned or very popular tool for managing or for handling huge amount of data, for handling big data. So whenever you hear a term big data, immediately the Hadoop comes into the picture with a big elephant with it. Correct? So Hadoop is responsible for storing, for managing, for handling huge amount of data. So let's say currently you have your offline structure, or if you have your offline system which is working in Hadoop. So you are in your own premises, you have set up the Hadoop. You had a setup for a Hadoop. Using that particular Hadoop system, your data is currently managed, your data is currently getting processed. Now, if you want to move that Hadoop cluster, See, Hadoop also works in a cluster environment where you have a multiple machines, and all those multiple machines are storing data. All those multiple machines are performing the processing in parallel. So this is what is a general Hadoop structure. So we also call it as a Hadoop cluster, right? So if there is a need to move this Hadoop cluster over the cloud, now why we need this Hadoop cluster to be moved on cloud? One thing is, if you have Hadoop cluster in your own premises, you will be responsible for managing that cluster. Managing cluster means if any of the node or if any of the machine in a cluster fails, then you are responsible for getting it repaired. If currently whatever number of nodes, whatever number of machines are there in Hadoop cluster, that number is insufficient, then arranging for new machines as a part of Hadoop cluster, you will be responsible. But if you move it on a cloud, your cloud provider will be responsible for managing all these things, for creating new machines as a part of your cluster, for repairing failed machine is a responsibility of cloud provider. So data proc is the same service. Using data proc service, we can have our Hadoop cluster installed on a cloud, right? So along with the Hadoop, whatever are the different products as a part of Hadoop ecosystem, whoever are very aware of Hadoop, they may understand this in depth. But else for rest of you, Hadoop is nothing but Hadoop is a tool which manages the big data. But apart from Hadoop, it also have some more sub products which are compatible with Hadoop or which are responsible for efficient working of Hadoop. Like we have a Spark for the faster execution of processing the jobs. Then we have HBase. So HBase is a kind of a storage which is compatible with Hadoop, kind of a thing. Then the pig is a scripting language. So if you have created your Hadoop cluster using Dataproc, still the support for all these different tools is also provided. So Dataproc is also have a huge support. It has an integration with all this rest of the tools which are part of Hadoop ecosystem. Now the question is, how will you move your Spark or the Hadoop jobs to the Dataproc? Simple, you just need to copy your data to the GCS bucket and you need to change the path of your data in your Spark job, in your Spark program from HDFS to GS. HDFS is nothing but Hadoop distributed file system. So when you use the Hadoop tool, that time your data gets stored in HDFS. But whenever you will have your Hadoop cluster in Dataproc, that time your data will be in GCS. So instead of HDFS, we are going to provide the path of data which is stored in the Google Cloud Storage. That's it. Nothing, no more changes will be there. Correct? Now, in case of Dataproc, we can have two types of clusters. We can have long-lived clusters. That means for individual tasks, we can have the individual clusters. But we can also use the ephemeral clusters. Ephemeral clusters means as per the requirement, we can have our clusters to be created. Right? Now, we can have Hadoop clusters in Dataproc as per our requirement. Let's say if I want in my cluster, I want to have 375 GB of local SSD, right? Cluster is nothing but it is a group of number of nodes. So if I want it in this way, so I can create my cluster as per requirement or as per the configuration of my business requirement. Whatever my business requires, depending upon that, I will configure my data prop cluster. Okay. Now this is a simple, so these are the different services which I wanted to focus, which I wanted to give you the overview, and which are majorly plays an important role for handling big data on Google Cloud, on Google Cloud, right? So now let's have a let's try to put together all these different services, and let's go back for the discussion of our data pipeline. So if you just remember, the first thing was ingestion. Ingestion is nothing but getting the data from the multiple storages, sorry, multiple sources, and putting it into cloud. So for that, we have a different services. If we talk about the real-time data, then we have a cloud pops up. We have a data transfer services. So if you want to transfer your data from your own premises into Google Cloud, then we have a data transfer service. We have a storage transfer service also. So in case of a storage transfer service, if we want to get the data from cloud, some other cloud or some other premises, then we have a storage transfer service also. We have a cloud IoT core. So if you want to get data from the IoT devices, then we can use this particular service. Next is, once you have collected data, if you want to process that data, then we have the option of a cloud data flow and the cloud data prop and the cloud data prep. So data prep is also one of the usual tool, but eventually whenever you are writing your transformation job in data pro in data prep, eventually the data flow task gets created at the back end. So that's why I didn't focus much on the data prep. Data flow is responsible for handling both type of a data, from stream data also and the batch data also. In case of a data proc, basically the data proc is used if you want to have Hadoop and the Spark jobs to be executed in Google Cloud. Once you have a process data, the next comes is a store. So we can store our data into the Google Cloud storage, or we can store it into the BigQuery, depending upon your requirement. So if you want your data to be further analyzed, if you want, you need to design machine learning model, then you can go for the BigQuery. If you just want to store, or if you want to keep your data for the longer amount of a time, then you can go for the cloud storage. Finally, once you have your data, you can use the BigQuery for the analysis purpose, and whatever data you have analyzed, those data can be represented in a visual format using this different visualization tools, or using this different BI tool, business intelligence tools, from where your stakeholders can make great decisions for their businesses. Okay. Apart from that, we have the cloud composer. We have cloud composer. So cloud composer is nothing but it is a fully managed workflow orchestration tool which is built on Airflow. Now we have seen at a different stage of data pipeline, we are going to require some different services. But we will require the coordination among all those services. So who will be responsible for coordinating all those services? So here the comes as a cloud composer. So cloud composer is responsible for coordinating among those services. Okay. This is a website where you can use the pricing calculator to check estimated price. So before start using any of the service, you always recommend that go and visit the pricing calculator, mention your details, like how much amount of memory you are going to require, how many resources you are going to require, and depending upon that, just have the estimation for using a particular service. Okay. uh, Now, before moving to this particular case study, let's have a small demonstration in which I'm going to show you data flow, cloud storage, and the BigQuery. Okay. So let me just stop sharing my screen for now. And till the time, I will just log in into my Google Cloud Console. If you have any queries till the time, you can just put it in the chat. So this is my Google Cloud Console screen. Okay. So here to the left hand side, you can see the list of all the services. If you go to the more products, you can find out the more services under the different categories. So this data flow service comes under the analytics category. Okay. Now here, what we are going to do is we are going to have one file in our Google Cloud Storage, and the contents of those files or whatever is written in that file, we are going to upload. We are going to add those contents into a BigQuery table. Okay, we are going to read data from the Google Cloud Storage file, and we are going to put it into the BigQuery table, right? And through data flow, in between we will have the data flow, right? So the first thing we will be doing is we will be enabling the data flow API. So in the search, we can just search for the data flow API. So go to the data flow API. Make sure this data flow API is enabled. So currently it is enabled. What I will do is I will just toggle the thing. I will just move it from the disable to enable, just to ensure it will be properly enabled. Enable. Okay. So this is the first thing which I will do it. Next step I'm going to do is I'm going to create a data set in BigQuery. So I'll go to the services. I'll go to BigQuery. In BigQuery, first we need to create a data set. Done. So here we will create a data set. So creating a data set is same as creating a database in case of your MySQL. So I will name my data set as taxi rides, multi-region, enable the table expiration. I'll not set any value over here. and just click on the create data set. Once your data set has been created, then the next thing is we will create a table inside that particular data set. So go to the data set, create table. So create the table from empty project data set. Name of the table, I'll specify here. The name of table is real time. For creating table, I need to mention the schema. Schema means what will be the structure. So I will edit as a text, or you can just do it row by row. You can keep on adding the individual fields. So I'll just mention the schema. I already have the schema, so I'll just paste it over here. So according to the schema in my BigQuery table, I'm going to have ride ID, which is of a string type, point, IDX, integer. So this is nothing but this is a schema, and I will populate values related with this schema from the Google Cloud Storage file. So I'll just click on the create table. Okay. Now I will go back to the Google Cloud Storage. Here I will create one bucket. So Google Cloud Storage, click on the create button, specify the bucket name. Always remember that your bucket name should be universally unique. So there should be no bucket of same name in the entire world. Okay, so this is my bucket name. Choose where you want to store the data. Whether your data should be in the multiple region, dual region, or region, you can specify that. Choose the storage class as we have just discussed. Auto class. Auto class means automatically your objects will be transit from one class to another. Which class you want? Standard, short, best for the short-term storage and frequently accessed data. So they have just mentioned. Choose how to control the access to objects. Do you want the fine-grained access? So that specify the access to individual objects by using the object level permissions. You can specify to whom you need to allow access to your objects. Correct? If you want to enforce a public access prevention, so you can just enforce it. That means your object will not be accessed publicly through the internet. Now, how you will choose to protect your data? So do you want to have an object versioning? Do you want to have the retention policy? If we set the retention policy, then nobody can delete your data. Nobody can delete your data. Fine. That's it. We will keep all the settings by default, whatever is already provided to us. Click on the create button, confirm. So currently we have just created a bucket. Okay. Run the pipeline. So now we will create the data flow pipeline. We will create a data flow job. So this data flow you can find out in the analytics part. Click on the data flow. So here, create the job from template. In case of a data flow, we can create the job from template. Template means which has given you the actual design, or it is a predefined design. Template is nothing but the predefined design which has already been given to us. Or else we have a different options. We have a workbench also. So in case of a workbench, if you want to write your own code for designing a data pipeline, so you can use the workbench. If you want to create the pipeline using SQL type of a code, then we can go for the SQL workspace. So currently I will choose the create job from template. So click on the option create job from template. Let's mention the job name over here. So I'll mention the job name as IoT flow. Okay. Select the region. Select the region as US East 1. Right. Data flow template. So just expand this. Here you can see process the data continuously. So what different templates are here? BigQuery to BigTable. That means whenever new data will be written into the BigQuery, it will be immediately updated in BigTable. Whenever there are some changes into the BigTable, it will be immediately reflected into the HBase. So here what we will be doing is we will be using PubSub topic to BigQuery. So whenever there is a new data which will be added into the PubSub topic, it will be reflected into BigQuery. Whenever we will have some data into the PubSub topic, if let's say some producer has produced some data into the PubSub topic, immediately it will be written into the BigQuery table. So BigQuery table will be the consumer. BigQuery table will be subscriber for a PubSub topic. So I'll select PubSub topic to BigQuery. Similarly, this is what is for the streaming data. If you can see, we have a templates for the batch data also. We have templates for the batch data also. Okay, so currently I have selected PubSub topic to BigQuery. Here we need to mention the topic name. From which topic we need to read the data. From which topic we need to read the data. Okay, from which topic we need to read the data. So just expand it, enter the topic manually. So we will mention the topic name. So I have already created a topic in PubSub. So I will be just mentioning that topic over here. I have already previously created a topic. So let me just mention the topic name. So again, whenever you are mentioning topic name, the format is projects, my project ID, your project ID, topics, and my topic ID. Same. Next is BigQuery output table. Now, whenever the data will be written into the topic, this data to be updated in which table, in which BigQuery output table. So here, the table which we had created, we will mention the name of that table. So this is nothing but this is my project, taxi rides dot real time. So taxi rides is nothing but name of data set, and real time is nothing but name of table which is part of a taxi rides data set. Finally, we need to have a temporary location. So this temporary location, we will specify our bucket which we have created. Now, why we need the temporary location? Yes, gone wrong. Okay. Why we need the temporary location? Because as I mentioned, whenever your data flow job will be executed, here if you can see to the right hand side, so this is nothing but this is the graph. This is nothing but this is a directed acyclic graph. This represents what different transformations or what different processing is going to be done on your data. So whenever this processing is happening, whatever will be the intermediate data, this intermediate data needs to be stored at some temporary location. So you need to specify the temporary location over here. For the encryption, what type of encryption you need to do, whether you want to have the Google managed encryption key or whether you want the customer managed encryption. And finally, we will just click on the run job. So here it will show you your job name, job ID, which type of a job it is. It is a streaming job. Streaming job means it is a continuous moving job. It will not stop ever because it's a streaming job. Now here, if you can just expand each and every step, what it says, map the elements. So this is also running, this is also running. If you can see, the each and every step is in running stage itself. Why? Because it is a streaming job. If you select the batch type of a job, then after a while you can see the job status as completed. Okay, so it is a continuously moving job. It is moving on. Here you can see map to record, invoke the UDF, JSON to table road, write the successful records, something like that. So this is going on. These are the in between, pops up unbounded source. So you are receiving your data from the pops up topic. That's why it is mentioned as pops up unbounded source. Once the data has been received, you need to map your data to the P collections, because this is what we have created. Now internally, though we have selected the template, internally whenever this is happening, it is in the form of it is in the form of a Apache Beam. It is in the form of Apache Beam. Right? Okay, so this is one thing. Now our job is continuously running. Now according to our job, what has to be done is our data has to be populated in BigQuery table. So now let's go back to the BigQuery. Previously, we have just created a table. We have not populated anything in that particular table. So this is a data set which we previously created. Inside a data set, we have created table also. But we have not added anything into a table. We have just defined a schema for that table, but we have not added any data into that table. Now let's check some data has been added into that table or not. So for that, go to the query or just open the another tab and just write down the query. So we will just mention the select query. Select star from project name. This is a data set and this is my table name. So let's run this. So let's see. Some of the data has been populated in my BigQuery table. From where did it come? So this data has come from the pub subtopic and it has been written over. Okay. Now, if you want to save these results, we can save it into the CSV file, JSON. We can copy this into another BigQuery table. We can upload it into the Google Sheets. If you want to explore your data, you can explore it with Sheets. You can explore it with the Looker Studio. You can explore it with the Python notebook also. So if you want to visualize, you have these different options also. Okay. So this was a small demonstration which I wanted to share with you just to understand. These are the different services which are provided by GCP for handling big data. Okay. Now I'll just take you back to PPT just to have a brief discussion about one of the case study on which I had worked on previously. So I'll just share that screen now. Okay, so as a part of this case study, what was the objective? So as a part of this case study, we were getting the air flight data, right? So daily air flight data was getting received. Daily, we were receiving one file related with the flight details. Now, in that flight details, what was the data from where the flight is starting, where it is ending? Apart from that, we used to get the weather data. We used to get the weather data for source and the destination, right? And the objective here was by considering weather data, we need to predict whether the flight will be delayed or not. Yes or no? That one was the our objective. Considering weather data, we need to decide whether the flight will be delayed or not, right? So this was the objective. Considering weather data, flight delay or not. Okay, so this was our objective to decide. So in this case, whatever first the thing was, before predicting the new data, the first thing was we need to train the machine learning model with some historical data, right? So what we had done is we had collected our historical data, we had gathered that data into a cloud storage. So for us, the cloud storage was our data lake. Initially, we gathered the historical data, and eventually, whenever we used to get the new files regarding weather data, we used to put it into the cloud storage. Then, after that, in between, we have used the data flow for processing that data, and we have added that processed data into the BigQuery. And here at the BigQuery, we have designed, or whatever data we have got it over here, instead of designing, we have created the machine learning model in BigQuery, and eventually we have deployed it using the Vertex AI. Now, for coordinating, for orchestrating such multiple services, such multiple GCP services, we have made use of a cloud composer. Okay, so this was the thing which we have done. This is a small architecture where we can just imagine how we can use the multiple GCP services altogether. So thank you. This is all about today's session.